Hello everyone, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical Engineering at YourPedia. In this class today, I am going to discuss one good question for CGPDTM, Controller General of Patent Designs and Trademarking Electrical Engineering Mains paper. One very good descriptive question I am going to discuss. So the main motto of this session is how to write descriptive questions such that you can score maximum marks from your writing. Okay, how to write, what is the procedure, step by step procedure, and what is the given data, everything we will understand with respect to that question. Before I enter into that question, let's see the paper. Okay, how the paper is, how many sections it is going to have, and for each section how many questions it is having, what is the weightage of each question. The total marks are of 300 and the examination is of 3 hours. Okay, and here if you observe, total there are 4 sections: section A, section B, section C, and section D. Right? In section A, yes, there are 2 parts, A and B. 2 parts, there are A and B, and there are 3 questions. 3 questions. Each question carries 12 marks. 12 into 3 is 36. Section B is, yes, it is also having 2 parts, A and B, and it is also having 3 questions. Each question carries 20 marks. 20 into 3 is 60. Section C is, it is also having 3 questions. It is also having 2 parts, A and B. Each question carries 28 marks. 28 into 3 is 84. Section D is, it is also having 3 questions. It is also containing of 2 parts, A and B. Each question carries 40 marks, so 120. 120 plus 84 plus 60 plus 36 will be 300. So total it is of 300 marks, and the examination is of 3 hours. Calculator is allowed. There are a good number of calculations involved in the descriptive paper, right? So let us discuss one question, very good question from power systems in electrical engineering, power systems. Okay, that is 11B, question 11B. So you know that that is the last section, section C. It is 11A. Let's discuss 11A, not B. 11A, one of the good question. 11A, read it, all of you read it. 11A, and this question is of transmission line part. What he is saying in this question: the ABCD constants of a lossless. Let me see, the very first thing anyone should do is write on the given data. See, take the question number and 11A is the question. He's saying that the ABCD constants of a lossless 3-phase 400 kV transmission line, that 400 kV is the given voltage, line to line voltage it is. Okay, so V receiving end is equal to 400 kV. This is in bracket line to line, line to line. So you may be thinking, sir, why it is receiving end voltage, why not it is sending end voltage? Always in the given data, if nothing is mentioned, the given voltage is always receiving end voltage, that to line. Yes, and the ABCD constants are, I'm taking in the form of matrix A, B, C, D is equal to, ABCD is equal to, yes, what are the values given? A 0.9, B J 200, yes, C J 0.001, and D is 0.9. Yes, they are the ABCD constants of the given transmission line. Yes, the line is having series compensation at both sending end and receiving end with a capacitive reactance of J 25 ohms. Yes, he is saying that the transmission line is having series compensation at both the ends with a capacitive reactance of J 25 ohms. It is plus J 25 ohms. Observe it here. It is given in the paper. This paper is 2018 descriptive paper it is, right? Let's take a white page and we solve there. Let's take white pages and we solve, right? Observe here, all of you. This is the given data. He given receiving end voltage is 400 kV and this is line to line. Yes, and the ABCD constants are A, B, C, D constants are, yes, this is 0.9, this is J200, this is J 0.001, this is 0.9, right? And he is saying that the transmission line is having series compensation at both the ends. Now let me show you diagrammatically. Yes, this is the transmission line. Yes, it is having ABCD parameters. This is the ABCD parameters of the transmission line. Yes, this side is sending end. At sending end side, yes, we have a series compensation of, yes, series compensation of plus J25. See, capacitor reactance XC is equal to, yes, 1 by omega C. When we are writing Z of capacitance, yes, minus JXC we write, minus JXC. But the examiner himself given it as plus J25 ohms, plus J25 ohms. We can go back to the question and we can verify, yeah, that fellow given, yes, both sending end and receiving end with a capacitor reactance of J25, himself mentioned it as plus J25. We have to do nothing, we have to take it, right? But that is not practical because capacitor reactance is always negative. So reactance is XC only, but when it is represented as impedance, Z is equal to R minus we get. For inductance it is R plus JXL, this is minus JXC, right? But this fellow given J plus J25, as he mentioned here J, yes, plus J, I have to take it as impedance. Sorry, I have to take it as impedance plus J25, right? Yeah, and both the ends is same. This end also he mentioned this is plus J25 ohms, right? And this is the receiving end. This is the receiving end, and this is the sending end. This voltage is Vs, this current is Is, yes, this voltage is VR, this current is IR, right? Yeah. Now observe carefully, all of you observe carefully here. Now he is asking, what he is asking? Let's go back to the question. Let's go back to the question. Now determine the sending end voltage, current, power factor, and the voltage regulation. He is asking us to find sending end voltage, yes, Vs, sending end current, sending end power factor, and voltage regulation. We will see the voltage regulation formula also. Voltage regulation. When the compensator line delivers a load of 750 MVA at 0.8 power factor lagging at 400 kV, this fellow says that the compensated line means this line is delivering yes, S load apparent power is 750 MVA, and the power factor of cos phi of load, or let's write it as load power factor. What is this? Load power in MVA. Load power in MVA. So this much load that particular compensated transmission line is delivering, right? And load power factor is equal to load power factor is equal to 0.6 lag. 0.6 lag. What else even? Load power factor is 0.6 lag. Yes, 0.8 power factor lagging it is, sorry, not 0.6, 0.8. I'll correct it. And receiving end voltage is 400 kV. Yes, and receiving end voltage is 800 kV. 400 kV. And load voltage. So where the load is kept? Load is connected to receiving end. Yes, load voltage or receiving end and voltage. Receiving voltage is equal to 400 kV. I told you if nothing is mentioned, by default it is line to line voltage. By default it is line to line voltage. This is the load data. Now what is asking? To find Vs, Is, sending end power factor and voltage regulation. What is expecting from us? He is asking us to find Vs, find Is, find cos phi s. What is cos phi s? Sending end power factor. Sending end power factor, that is nothing but cosine of angle between Vs and Is. Cosine of angle between Vs and Is. Vs and Is. And voltage regulation. Voltage regulation. What is voltage regulation formula? Yes, no load receiving end voltage. See, no load receiving end voltage minus full load receiving end voltage by full load receiving end voltage. This is voltage regulation. What is this V no load? How to get V no load? That we'll see. Then see, these things he's asking. He's asking us to find these four things, right? Now for this one, we must have some relationships or some formula. We all know that Vs is equal to AVR plus BIR, sending end voltage. Sending end current Is is equal to CVR plus DIR. So in this one, see, if I use this formula, I will get both Vs and Is. But how many are known for me here? How many are unknown? I have to check, right? Here VR I know, VR, that is equal to 400 kV by root 3. You may be thinking why I taken, yes, by root 3. Why I taken by root 3? Yeah, VR per phase. I taken here by root 3. Why? Because I have to take here per phase voltage. Why? Because A, B, C, D are always per phase quantities. I'll stress at a point here that is only voltages, current, power are for line and phase differs, but A, B, C, D are parameters. R, L, C, G are parameters. Those are always per phase only. Never line to line inductance will exist. See, voltage is line to line between two lines. If you are observing, if you are calculating some voltage, that is called as line to line voltage. But parameters are always per phase. Let me write a note point here. Write a note point here. Parameters are always, note, parameters are always per phase. Parameters are always per phase. So if ABCD are per phase, then definitely VR and IR must be per phase quantities only. That's why VR I taken by root 3. Yes, and I have to take the angle of VR as 0 degrees. Why? Because always receiving end voltage is taken as a reference. Yes, in power systems we will take always receiving end voltage as reference. Then its angle will be 0. Now I have VR. I do not have IR. I do not have ABCD. You may be thinking, sir, we have ABCD. These ABCD are the line without compensation. Now, after compensation, yeah, let's go back to the question. Read it. A transmission line A, B, C, D given. The line is having series compensation at both sending end and receiving end with a capacitive reactance of J25 ohms. Without series compensation, A, B, C, D, that fellow given. Now, after series compensation, definitely A, B, C, D parameters or constants will change. Then I have to find the new A, B, C, D parameters of this particular line. Yes. Now, these are the A, B, C, D constants of this particular transmission line without compensation. See, this is without compensation. This is the transmission line. Right? After compensation, I have to find what are the ABCD. For this one, I have to find ABCD parameters. That also we'll see. Now, observe here, I have to find ABCD and IR. If I find ABCD and IR, I'm going to get Vs and Is. Once I have Vs and Is, the cosine of angle between Vs and Is is sending in power factor. Already Vs and Is we have 3 already done. Then I am left with the last one, that is voltage regulation, right? Now, observe here how to find ABCD parameters. Let's see. Yes. Yeah. Resultant ABCD parameters. Resultant ABCD parameters of the compensated transmission line. Compensated, yes, transmission line. compensated transmission line. How to find? Yeah, this is our line after compensation. This is my line after compensation. This is capacitance, and these are the previous ABCD parameters. Yes, this is ABCD. Let me put the values directly here. Okay, this is 0.9, this is J 200, this is J 0.001, this is 0.9. Yes, 0.9. Let me put in matrix, right? And this is capacitance. Now, so how to find these ABCD parameters? There are several methods, but one of the very good method I'm going to take up, that is I'll divide this diagram into three parts. This is first part, this is second part, and this is third part. We all know that if networks are connected in cascade, then their individual ABCD parameters will be multiplied. What is cascade connection? Output of the first section is given to the input of the next section. This is section 2. First section output is this. Second section input is this. Both are connected in cascade directly. Therefore, it is called a cascade connection. Output of the second section is connected to input of the third section. Yeah, I'll write this one as a first section. First section. This one as second section. Yes, this one as third section. This one as third section, right? Three sections we have. Now a note point again here, a note point. If systems are connected in cascade, if systems are connected in cascade, then their ABCD parameters will be multiplied. Then their ABCD parameters will be multiplied. Right? Now we have the first section. This is the first section. First section is having a compensated capacitor. Yeah. What are the ABCD parameters of this one? This is 25 ohms. Now let's find. I'll take like this. I'll write this one as some V1, this one as V2, this one as I1, this one as I2. Right? What are the ABCD parameters? Vs is equal to AVR plus VI, or otherwise let's take it as Vs and Is only. What is the problem? I'll take it as Vs, Is, VR, IR. But these are not ultimate Vs, Is and VR, IR. Okay, please do remember. Vs, Is. Sorry, these are R, right? This is VR, this is IR. Write down the equation. Minus Vs, yes, plus Is into all are having Is into all are I can say like phasor quantities, plus VR is equal to 0. And I know one thing, that Is is equal to IR because it is simply a series circuit. It is simply a series circuit. Is is equal to IR. Now let's rewrite this equation. So Vs is equal to, in the place of Is I substitute this IR. First let me write VR plus IR into J25. So this is equation 1 I call. Right? So Vs is equal to 1 into VR plus J25 into IR. So this is equation 1 I call. Okay, let's not give any name to this equation. Okay, now Is is equal to what I got? Sorry, Is is equal to what I got? Is is equal to, yes, 0 into VR plus 1 into IR. This is equation 2. Let's write Vs, Is. This is, yeah, VR, IR. Yes, if you write, this is what? 1. This is what? J25. This is 0. This is 1. 1, J25, 0, 1. First section. These are the ABCD parameters of first section. Then Second section ABCD parameters we already have, that is given by the examiner, 0.9, J200, J0.001, 0.9. Third section is similar to first section, na? Yes. Third section is same as that of this first section. You see, third section is similar to this first section. This is also J25, that is also J25. Now I am getting overall all ABCD parameters. A equivalent, B equivalent, C equivalent and D equivalent is equal to, what is the first section? 1, J25, 0, 1. Second section is 0.9, J200, J0.001, 0.9. The next section is 1, yes, J25, 0, 1. Because third section and first section are similar. Third and first sections are similar, right? Now I have to perform this multiplication. So be careful when you are simplifying. There are a lot of chances of committing mistake when you are simplifying. That is mandatory. Okay, so that's why I'll perform slowly. If there is any mismatch in my multiplication, please let me know. Okay, yeah, I'll multiply these two, then I'm going to get the first element. See, I'll do 1 into 0.9 plus J25 into J0.001. So first one is 0.9 into 1, yes, minus, because J25, J0. J square minus, it is 25 into 0.001. So I got it as 7 by 8. I got it as 7 by 8, first element. Then this part with this part will give the second element, right? That is J200 minus, yes, 200 minus, no, not minus, it is plus only. Sorry, this is 1 into J200, that is J200, J25 into 0.9. Here we got minus 5 because this J25 into J0.01, J square, it is minus 1. But this one with this one means 1 into J200, 200, 25 into 0.9. 200 plus 25 into 0.9 is 445 by 2. It is triple to 0.5. One should not forget this J, otherwise gone. Okay, this is parameter B. Parameter B is impedance lossless. Na? If it is a lossy line, R plus J XL you will get. As it is a lossless line, R part is 0, resistance is 0. Now this one with this one will give element C. 0 into 0.9 is 0 only. This is 1 into 0.001. This is 0.001 only. 1 into 0 into 0.9 is 0 plus 1 into J0.001. Now this into this we have to do. How much is this? 0 into J200 is J200. Sir, 0, 1 into 0.9 is 0.9. Right? We got it. Multiplication of these two we got. Then we are left with a multiplication of these two parts. 1 J25. This is 0, 1. Let's do this. Let's do this. I'll do here. Yes. Observe. So this is first is this one with this one. So 7 by 8 into 0 into J225 will be, this is 7 by 8. Yes, 7 by 8. Second one is this one with this one. Then how much I am going to get? J 7 by 8 into J25. 25 into, yes, 7 divided by 8 plus 222.5. This is simply 244.375 J. J 244.375. This part will be this into this. J 0.001 into 1 plus 0.9 into 0. This will be J 0.001. J 0.001. Now this one will be this into this part. So 0.001 into J25. 0.001 into 25, that is minus. Why? Because J into J will be J square plus 0.9 into 1 is, yes, yeah, 7 by 8. Yeah, you observe here. We got A equal to D. We got A equal to D. Symmetrical line The transmission line what we taken is a symmetrical transmission line. If a transmission line is symmetrical, A must be equal to D. If it is reciprocal, AD minus BC is equal to 1. A practical transmission line must be symmetrical and reciprocal. If not, suppose you are not getting A equal to D and AD minus BC is equal to 1, it is not a practical transmission line. We got the new ABCD parameters. Now let's copy these ABCD parameters in the next page, then perform our task. 7 by 8, 244.375. Yeah, let me write here. A equivalent, B equivalent, C equivalent, D equivalent, right? First one is parameter A is 7 by 8. Definitely D must be equal. This is 244 point. This is a J 0.001. There is no change in this one. J 244 point. Yes, J 244.375. 375. Maintain at least 3-digit accuracy after the decimal point. After decimal point, at least 3 digits. Okay, answer accuracy is also very important in the examination. So now tell me, what is VS? VS is equal to AVR plus BIR, but we do not have IR. Yes, load power is equal to root 3 times of V load into, or simply instead of load is connected to the receiving end. SR is equal to S load is equal to 750 MVA. That is the given data. Root 3 times of VR into IR, or root 3 times of VR into IR. Root 3 VR into IR. Yes. Okay, that is S. Now IR is equal to how much I am going to get? IR is equal to 750 into 10 to the power of 6 by root 3 times of VR is 400 into 10 cube, right? This is line to line. This is line to line. This is line to line. Okay, from this one we will get magnitude of IR. Magnitude of IR. See, from where we got this one? S is equal to root 3 VL IL. This is the formula. All this data is given in the given question. Load MVA given, load voltage given. From that I am finding load current. So IR magnitude I am going to get how much it is? 750 by 400 into root 3. Yes. The current is 1082 point. Yes. 1082.531 amperes. Yes. I got the current as, yes, 1082.531. So IR magnitude I got it as 1082.531 amperes. Now IR in the form of phasor will be 1082.531 at an angle of minus. Why minus? Load is lagging load. Cos inverse of what is the power factor that fellow given? Examiner 0.8. What is cos inverse of 0.8? Cos inverse of 0.8 is 36.86 degrees. Yes, IR is equal to 1082.531 at an angle of minus 36.8698 degree. This is the correct. Now very simple to find VS. VS is equal to A. A is how much? 7 by 8. Yeah, we got the values. VS is equal to 7 by 8. A, D, B, C. Yes, VS is equal to, what is the B value? 244.375, right? Yeah. VR is what? 400 by root 3 into 10 cube. Yeah, 400 by root 3. VR per phase voltage only we have to take. I told you VS is equal to AVR plus B. What is B? J 244.375. IR, what is IR? 1082.531 at an angle of minus 36.8698 degree. If I do this, I am going to get a sending end voltage. How much it is? Let me calculate. 400 divided by root 3 into 7 divided by 8 into 10 cube plus, yes, let me, 1082.531, in fact 531 at an angle of just a minute, at an angle of minus of 36.8698, yes, into current into that B we have to do na, B, that parameter B is 244.375 I. In calculator we will get it as I, right? Now if we do this, if we convert this one into, yes, polar form, we got it, I got it as in rectangular form. Let me convert this one into polar form. If we convert this one into polar form, yes, just a minute, yeah. So from this one we are going to get, or otherwise let me write in rectangular form itself, 360,798 plus, sorry, I told you to write up to 3 decimal points na, plus 0.3414 plus j 21635.081. So this is the voltage what we got, sending end voltage. This is per phase voltage. You should not forget that it has per phase voltage. That is per phase voltage. Because we taken V, A, B, C, D are as per phase values. Therefore, we taken A, B, C, D, VR also per phase. Therefore, we got VS also per phase. After this, we have to find IS. Once we got IS, 80% of the problem is done. Then we have to see VS is one thing, IS is another thing. Okay, but VS have to convert into again a line value. Then in the last we are going to find voltage regulation. So after this we have to find voltage, current, IS current I have to find. Let's calculate the current IS. Yes, we know the formula, IS is equal to CVR plus DIR. We have the values of everything, yes, everything we have. C is J 0.001, VR is 400 by root 3 into 10 cube, plus D is 7 by 8 into I is 108.2.351 at an angle of minus 36.86 degree. Let me check the current I, 1082.531. Do this, we get IS as, let me do it 0.001 into I into 400 divided by root 3 into 1000 plus 7 divided by 8 into 1082 point, I think it is not 351, it is 531. Yes, it is 531 at an angle of yes minus 36.86, right? Yeah, so I got it as 757.8698 minus 337.2577J. Convert this into polar form. Why? Because as I want to find power factor, sending end power factor angle, as it is the angle between sending end voltage and sending end current, I need in polar form, right? Yes. If I convert into polar form, I got it as 829.5236 at an angle of minus 23.989 degree, right? So I'm putting this one in box. In the same way, VS also write in polar form. What is that? 360,798.3414 plus 211,635.081 I, right? I'm converting this into polar form. Yes, I'm converting this into polar form. Yeah, just allow me a moment. I'll convert this one into polar form. Yeah, I got it as 418.28799 at an angle of 30.3947 degrees. This is in kV. I'll put this one in box. Now we got Vs and Is. I got the angle of Vs and Is. What is cos phi s sending end power factor is cosine of angle between voltage and current. Yes, observe here. What is this Vs angle I got? 30.3947. Yes. Now here I am writing sending end power factor, or let me take a new page and in that I'll write sending end power factor is equal to sending end power factor is equal to cos phi s is equal to cosine of angle between Vs and Is, that is equal to cos of what is Vs angle 30.394 minus between means I have to subtract what is Is angle minus 23.989 minus 23.989. So you may be asking, sir, why you are subtracting? See, this is reference 0 degrees. This is plus 10. This is plus 5, I can say. What is the angle between these two? If I want, that angle is 15. As it is leading, this is plus, it is lagging, I have to take it as minus. As it is up, plus, it is minus, it is down minus. This is the reference 0. 0 downside minus upside plus only. Na? All anti-clockwise angles are positive, clockwise angles are negative. We studied in electrical engineering. What is the angle between these two? 15 degree, not 5 degree. Okay, you see, this is 10, this is 5, then total will be 15. That's why I am subtracting. Okay, observe carefully. Here. Now cos of how much this is? 30.394 plus 23.989 cos of this is 54.383, that is equal to, it is 0.58 lag. Sir, how do you know that it is lag? Current is lagging, current angle is negative, voltage angle is positive, right? We did three things. One is, see, this is the answer. One is sending end voltage, sending end current, sending end power factor, and the last but not least, that is voltage regulation. What is voltage regulation formula? Voltage regulation is equal to no load voltage at the receiving end minus full load voltage at the receiving end by full load voltage at the receiving end. Full load voltage at the receiving end given by him, that is 400. He mentioned load voltage is 400 kV, load power is 750 MVA, load power factor is 0.8 lakh. He mentioned, right? This is there. Now what is, let me write to the description also. You have to write the description. What is that? Magnitude of no load voltage at the receiving end side. Yes. What is VFL? Full load voltage, magnitude of, I forgot to write, magnitude of full load voltage at the receiving end side, right? Now observe here, we have VFL. How to get V no load? We all know that Vs is equal to AVR na plus BIR. Under no load, yes, IR is equal to 0. If IR is equal to 0, Vs is equal to, this is nothing but V no load na. Why it is V no load, sir? Why it is V no load? Because as current is not there, the receiving end voltage is nothing but no load receiving end voltage. From this one, V no load is equal to Vs by A, magnitude I want. What is Vs? We got it as yes, we kept in a box, that is 418.28799. Yes, 418 point, yes, I forgot, 28799, 28799 at an angle of 30.59 degree by A is 7 by 8. It's a magnitude we want. Yes, this magnitude we want. So 418.2899 at an angle of 30.59, yes, divided by 7 divided by 8, only magnitude we want. I think it has to rise. Why? Because 7 by 8 is less than 1. 418. Okay, let me convert into this polar form again. Yeah, I got it as 478.0456 kV. All these are in kV. I got no load voltage and full load voltage. I got no load voltage and full load voltage. Observe, voltage regulation is equal to 478 point, how much it is? 0456. 0456 minus 418 by 418. Yes, 478.0456 minus 418 divided by 418, that is equal to 0.1436. If we want percentage voltage regulation, that is equal to 0.1436 into 100, that is equal to 14.36, right? So this way we have to calculate. See, this is the procedure. Every formula you have to write, every formula, and procedure clearly you have to mention. I wrote clearly here, if systems are connected, networks are connected in cascade, their ABCD parameters will be multiplied. I followed there, right? Yeah. See, let's go back to the question and see whether we answered everything or not, step by step. Yeah, we calculated sending end voltage, sending end current, power factor, and the voltage regulation. Everything we found. Very good question. This question is given for 20 marks. Okay, so section D is having 3 questions. Each question is of 40 marks. 40 into 3 is 120. In this, there are 2 bits, 11A and 11B. 11A is of 20 marks, 11B is also of 20 marks, right? So this way we have to answer the given questions, procedure wise, every formula, and neat calculation with good accuracy. Calculator will be allowed, right? Without calculator, these calculations, it is impossible, right? Calculator will be definitely allowed in the examination. Okay, all the best. Join your hands with YourPedia for your CGPDTM preparation. Thank you.